So hi everyone, I'm Prashant. I am a postdoc in ECS. My primary research area is cryptography and the theory of cryptography. And what you're about to hear is the result of one of our projects studying certain concepts from recent data protection laws from a cryptographic point of view. Hope you enjoy the lightning talk.
Hi, my name is Prashant, and I'm going to tell you about some of our recent work on formalizing data deletion in general systems. This is based on joint work with Sanjam Garg and Shafiq Goldwasser, both of whom are also in Berkeley. The broad context for our work here is the fact that a lot of data is being collected about us every day by various different entities, and this data in turn affects our lives in different ways. This being the case, there is a need that is felt to regulate how this data is handled. And consequently, several legislations have been enacted across the world which seek to do this, which seek to regulate the handling of this data. Good examples of this are the GDPR in Europe and the CCP in California. And these laws, they seek to give individuals more control over how their data is handled. And they give them various rights in this regard. One of the more interesting of these rights is what has come to be known as the right to be forgotten. This may be found both in the GDPR and in the CCP. And very roughly, this right is the right of an individual to ask that their data be deleted. If a company holds my data, I can go up to them and ask that they delete my data. And with certain exceptions, they have to do this. What we ask in our work is what this means, is what does it mean for this company to delete my data? On the face of it, it seems like a simple question, right? Like I have your data on my computer and I just delete it. However, there are certain complications here. A very simple consideration here, for example, is that data that I have stored and deleted could still have left traces in the memory. When you delete a file out from your hard disk, for instance, it doesn't actually just go away, right? Unless you're very careful about it. And there are considerations like this. The data by most entities these days is not just stored, right? They also process this data. They come up with machine learning models based on this data. They come up with statistics based on this data. And what does it mean if the entity just deletes your data but keeps whatever processed information they have? Is this legitimate? Is this fine? And finally, it could be the case that one company shares your data with another company to provide you with some service. And what does it mean now? If you ask company A to delete your data, do they have to go and ask company B to delete your data? What does deletion mean in the presence of all of these considerations? Right? And this is sort of what we ask. We identify this need to precisely define and understand the behavior of systems, or specifically computer systems, with respect to data deletion. And what we do in our work is we come up with a model to study this, to study data deletion, and with a couple of candidate definitions for what data deletion could mean. So right now I'm going to tell you about a little bit about this model and one of our definitions. This is how we start. So we start with modeling this data collector, which is an entity which collects people's data, and it has this memory on its computer systems. It could be the hard disk, it could be the RAM, whatever we are concerned about, whatever memory we are concerned about. And there is a user whose data we are interested in, and a bunch of other people in the environment. There are other users, other companies that constitute the environment, the rest of the world. The user communicates with this data collector in a specific form that's convenient to talk about, and eventually asks for their content to be deleted. It sends some messages and then asks for their messages to be deleted. It does this, and the data collector runs its deletion algorithms and updates its memory. And at this point, we want to ask, has the user's data left the rest of the world? Have all traces of it been removed? And we want to do this by comparing it to a different world, an idealized world, where the user never even talked to the data collector, right? So in this world where the user never talked to the data collector's memory has nothing. There's no information about the user in the rest of the world. And we want to say somehow that the world on the left looks similar to the world on the right if the data collector is doing things correctly. Right? And we call the world on the left the real world and the one on the right the ideal world. And we add some additional communication channels to make things more general. And we place a couple of restrictions on how the users can behave and how the data collector and the environment can behave. And under these restrictions, we ask the following. We look at the memory of the data collector, and we also look at the communication that the environment has with the data collector, everything that the environment learns from the data collector. And we look at these quantities, look at these aspects of both these worlds, and we ask that they look very similar. Like if you look at the distribution of the memory and the communication of the data collector, it looks the same in both the worlds, or very similar at least in both the worlds. And in this way, the world on the left behaves like the world on the right. And we can say that the data collector has updated things to look as though it never learned the user's information in the first place. Right? This is one example of a definition that we have, and we discuss what this means, and then we discuss what intuition it captures and how it compares to other possible definitions in our paper, and it relates in interesting ways to various other notions of sets. Deletion and privacy that have been studied in other areas, and I encourage you to look into this in our paper. And I will end my talk here. Overall we have identified this need to discuss and understand deletion behavior in this way, and we have come up with a model and a definition for what deletion could mean, and we also draw a few lessons from this that again I refer you to the paper to learn more about this. Thank you.